When we think of optical art, names like Vasarely show us that behind the visual illusion there is always a rigorously geometric foundation. This tutorial doesn't seek merely to teach you how to draw a hemisphere. It aims to give you the technical foundations to do it with professional precision. The key lies in geometry. With only a ruler and a compass, no need for numerical calculations or measuring instruments, you will learn how to construct a grid that gives the real sensation of volume and depth, based on the principles of classical perspective. Imagine, from a small sheet of paper to a large wall, the same geometric principles can be applied without scale limitations. That is the strength of this method. Join me then on this initial journey. Today we will build together a hemisphere in the style of Vasarely, and we will do it with the mathematical precision that this art demands. Let's begin. We'll draw a line on which we'll define a segment that covers the total area of the drawing we are going to make. Taking the measure of the segment with the compass, or a substitute for it, we'll draw an arc from one end. We repeat the process from the opposite end, always keeping the same measure. From the point where both arcs intersect, we now draw an arc on the right end, as shown here. This will allow us to draw a line from one end of the segment that passes through the intersection of the first arcs until it meets the outermost arc. We repeat the same process from the other end of the segment. With this, we can draw a perfectly horizontal line above, from the end of the segment to the point of intersection of the diagonal that comes from the opposite end with the outermost arc. In the same way, we draw the lower horizontal. We now have two new intersection points, top and bottom, which give us the position through which the last vertical line will pass. With this, we will have drawn a perfect square that adapts to any size of our drawing surface, without having to take measurements or make calculations. We can now erase the auxiliary lines and arcs to keep only the square, which we will proceed to divide. We draw the diagonals connecting the vertices, which will give us the center through which we'll draw a vertical line and then a horizontal one, thus dividing the square into 4 equal parts. We draw the missing diagonals in the 4 resulting squares to obtain again a central point in each one, allowing us to draw new vertical and horizontal lines. With this, we have divided the original square into 8 equal parts. Again, we draw the missing diagonals in the smaller squares, but only in the 4 corners. Once this is done, we draw the corresponding verticals and horizontals, which will give us the necessary intersection points to complete the division with the following lines. Finally, we repeat the same process, drawing the missing diagonals in the 4 small corner squares to draw the lines that will divide our large square into 16 equal parts on each side. We erase the auxiliary lines to keep only the 16 by 16 grid, or if you prefer, 256 squares. Now we draw a circle from the center of the grid that covers 10 cells, leaving therefore 3 cells free on each side. For the effect of seeing a sphere to occur, we must reduce the size of the cells as they approach the edge of the circle. Although here, it is more accurate to say that what we are going to do is enlarge the cells as they get closer to the center of the circle. To achieve this effect consistently and logically, we will use a geometric resource typical of classical perspective, which will give us the exact measure of the squares as they approach or move away from the edge of the circle. Drawn in red, to differentiate it from the other lines, we will start by drawing a horizontal line that passes through the central point of the circle, which is also the center of the grid. Then we measure the diameter of the circle and proceed to mark an intersection point on the horizontal line outside the grid. This will be our vanishing point, toward which the lines we are about to draw will converge. Still in red, we draw a small vertical that covers 2 cells from the center of the circumference, one upward and one downward. From one end of this segment, we draw a line that intersects the mark we made earlier. From the other end, we do the same. We will draw a vertical line in the center of the second column to the right. If we draw 2 diagonals, as we've already done, we'll have the exact point through which this vertical will pass. This vertical line will mark the dimension of the first cells of the sphere, the ones visually closest to us. Now we must determine the size of the following cells. To do so, we draw a diagonal that goes from one end of the central segment we drew in red. passing through the intersection produced with the horizontal and the first mark we made to cut the upper line. This will be the point through which our next vertical mark will pass. We repeat the process, this time from the lower intersection left by the first vertical mark, crossing again the horizontal line at the intersection, reaching the upper line to obtain another intersection point through which the next vertical mark will pass. In the same way, we finish locating the fourth and last mark. Notice how the size of the cells decreases harmoniously as they move away from the center. Erase the auxiliary lines and keep only the vertical marks. Copy with the compass the position of each of these marks on the other 3 axes. Now you have everything you need to correctly deform the lines that will define the sphere. With black thick lines, we'll trace over the lines that make up the grid. Extend the lines to the edge of the circle when it coincides with the vertex of the cells. If not, stop at that vertex, leaving a free space. As you can see, here we draw the central lines, and now we continue with the drawing of the lines or arcs that will pass through the marks we made previously. Notice that these arcs do not always reach the circumference. This is because we must achieve a smooth transition toward the lines that define the circumference. Once the drawing of all the arcs that define the sphere is complete, we can now start talking about a sphere and not just a circumference. We draw the small connecting lines that will give us a smooth transition from the grid to the sphere. Pay attention to the 4 corners, where we must draw the cells bending as they rise along the edge of the hemisphere. To finish this drawing, we can add thin white lines at the center of each stroke to make the visual impact more interesting. The choice of color and its gradients, as well as the use of complementary colors along with tonal value and shadowing, all done with the same rigor and precision as the drawing itself, will be fundamental parts in turning this work into an artistic piece. For now, we will focus only on the drawing. And I leave you as inspiration and example.
If you enjoyed this video or found it helpful, don't forget to give it a like. Got questions or want me to explain something in more detail? Just drop a comment below. And be sure to subscribe so you don't miss upcoming tutorials. It also really helps me keep making more content. Thanks for watching. See you in the next tutorial.